This is question number 11 of our calculus review. Consider the curve f of x is equal to x minus x cubed. We first want to find the slope of the tangent line to the curve at the point 1, 0, find the equation of the tangent line in part A, and then graph the curve and said tangent line. So, in order for us to do this, for us to find the slope of the tangent line, right, we have our function f of x is equal to x minus x cubed, and our point P is at 1, 0. So that means our slope of this line is going to be the limit as x approaches 1 of our function f of x minus the y value from our point P, 0, divided by whatever x is, minus the x value from P, which is 1. So in our case then, this is equal to the limit as x approaches 1. We could replace this f of x in the numerator with the function x minus x cubed. We could just drop the minus 0 because that's 0, divided by x minus 1. But we could factor this numerator a bit. And this is equal to the limit. This is equal to the limit as x approaches 1 of, this would be x times x, x times, this would be 1 minus x squared divided by x minus 1. And that is the limit as x approaches 1. The 1 minus x squared also factors. This would be x times 1 minus x times 1 plus x, all divided by x minus 1. And well, stuff does cancel here, right? It's very important to note that x minus 1 can be rewritten slightly as this would be negative, this would be negative 1 minus x. Which would then allow us then to be able to cancel stuff out in that fraction. So let me just rewrite that denominator just so we can clearly and easily see the cancelization in it. So limit as x approaches 1 of x times 1 minus x times 1 plus x, all divided by rewriting the x minus 1 as negative 1 minus x. So now we can see that we could cancel out the 1 minus x. And that would leave us with the limit as x approaches 1 of, this would be negative x times 1 plus x. And well, there is absolutely no reason why 1 can't be put in for x here. This would make, substituting in the 1, negative 1 times 1 plus 1. So in this case, it gives us a value of negative 2 for that slope of the tangent line to the curve at the point 1, 0. For part B. For part B, and I need a bit more room for this, we want the equation of the tangent line that we just found the slope for in part A. So that would be based on y minus, since it's based on this point 1, 0, this would be f of 1 is equal to the derivative that we just found f prime of 1 times x minus 1. So in our case, filling this stuff in, y minus 0 is equal to negative 2 times x minus 1. So distributing in that negative 2, this should just be y is equal to negative 2x plus 2. And then for part C, they want to graph the curve and its tangent line. So just so we could see that specifically, let me pop this open here into Desmos so we can see it. Based on our original function, x minus x cubed. And I need to zoom out on this, as we are based on this point over here. Let me just pop that in there, just so we could see it a bit more clearly. Just so we could see the tangent line that was negative 2x plus 2. And you could see after I type that in, it directly hits this curve directly at that point 1, 0. And you can see that going in on this graph on here as I zoom in more onto it. Thank you.